Okay, so in the first unit we talked a little bit about the force of friction and what that is and how it plays a role in why objects move. Our second unit is titled Machines or Simple Machines, and so we're still dealing with that things that are in motion, but actually we're going to talk about things that help us with motion and maybe make things easier. So machines were invented to help make things easier that we do. And so we're going to spend a little bit of time looking at friction and breaking it down a little bit further into more detailed categories. And so we talked about friction just basically being something that opposes the force of motion that's happening. So if something's moving, friction's opposing that force, or it's in the opposite direction to what you're trying to do. So you probably watched the video, and sort of the big idea I want you to consider and think about while we work through this section is friction bad or is friction good? And what you should be taking away from it in the end is that there's sometimes that we need friction and sometimes that we don't want friction. So it can be good and it can be bad. So try and imagine a world without friction. So if we think of all of the reasons that we need friction, imagine trying to run. Could you do it? What about coming to a stop in a moving car? How would that work? And what about simply just turning a doorknob? So there's a certain amount of friction in almost everything that we do. And if it weren't there, we wouldn't be able to do half these things. So we need friction to be able to carry out regular activities like walking, driving, or just simply holding things. But on the other hand, there's lots of cases where we want to actually reduce the amount of friction that's involved. So if you think of race car drivers, they try to use techniques to reduce friction. We like frying pans with less friction that can slide easier over on top of a stovetop. And we don't want moving parts of a machine to have friction either, because what friction can turn into over time is heat from two objects that are in contact with each other, working against each other in the opposite directions. We end up getting heat created for that. And what happens is we end up reducing the efficiency of what we're trying to do. What was the other example? I was just thinking of our human bodies. So our bodies, all of our joints, we want to reduce the amount of friction in our joints, which is why there's fluids that are in our joints to try and lubricate the movement in our elbows and our knees and all of our joints that have moving parts to it. So friction, first of all, friction can be a great thing for some, and then it can be a bad thing for others. So what we're going to do is we're going to take a little closer look at two different types of friction. So, would it be more difficult to get this heavy cooler moving or to keep it moving? So what I want you guys to focus on while we're going through this note is we've talked about friction, we know what it is, but now we're talking about to get something moving from rest or to keep something moving once it's already going. These are the two types of friction that we're going to talk about, and that's the title of this note. If we go back up to the title, we have kinetic friction versus static friction. So right off the bat here, kinetic, the word kinetic, anytime you see it, because we are going to actually see it again in this course. When you see the word kinetic, it means moving. And when you see the word static, it's the opposite, not moving or at rest. So when we think about these types of friction, there's a certain amount of friction involved when we attempt to move something before it starts moving. And then once it's moving, there's also friction involved as it's sliding against the surface that it's moving against. So these are the two different types of friction we're going to talk about here. And so my question to you is it more difficult to get something moving from rest, or is it more difficult to keep something moving once it's already moving? So here we go. Static friction is the force of friction that acts on stationary objects, preventing them from moving. So something that's at rest, how do we overcome that amount of friction to get it moving? And then kinetic is the force that resists motion of moving objects. Okay, so kinetic means moving, static, stationary. In this case is another word for at rest. Something that's not moving is stationary. Okay, so what we want to think about, because we're familiar with the word force. So what kind of force is needed to get something moving versus what kind of force is needed to keep something moving? And they've put together this graph that sort of gives you the idea behind the relationship between something. So the first part of this graph, we can actually label it right on there, might make a little bit more sense. Here's what happens with a stationary object. or at rest. And the next part of the graph is, I believe, what's the wording they use here? Starting to move. And the last part in green is moving. And this is what happens to the amount of force that's required to get something in these states continuing to move or to start moving. So if you think about something that's not moving already, this is the increased amount of force that's needed in order to overcome the certain amount of friction that there is. Now keep in mind, depending on the objects that are involved in this frictional force, the amount of force might change. So for instance, for us to push a desk across a concrete floor is going to be a lot harder than us to push that same desk across ice. So the two contacts that are in surface are very important in determining how much force is actually going to be needed. But in general, what we're saying is that we have to overcome a certain amount of force to get something moving that's already at rest. Once it starts to move, the amount of force that we have to keep on that object actually starts to decrease. And then once it's moving at the rate or constant velocity that we want it to, it'll start to level out. The amount of force we're using to push it will be balanced by the frictional forces, and so it stays constant. So this is just to kind of show you what's happening to the amount of force when we start with something that's at rest, get it moving, and keep it moving. The amount of force changes. This is an interesting thing that came from the 2004 Olympic Games. Over half of the gold medal winners in the swimming competition at the Olympic Games were wearing suits. These were brand new suits at the time that they came out with that simulated the scaled skins of sharks, and they were amazing. They reduced the friction between the swimmer and the water better than any other suit that's ever been made. And so after that World Olympics, I think that what they did was they ended up banning those types of suits because they gave the competitors an unfair advantage over the others. And this was what they looked like. And so here's an example of where if we reduce friction, it helps us out. Okay, so to introduce this topic and for you guys to get a better feel for some of the factors that can affect friction, you're going to work through a lab activity. And so to answer the next questions, I'll just give you sort of a real life example that you might be able to relate to. And we're going to consider a cooler that's filled with food. How could we make it easier to move this cooler across the floor? So I gave you one example. We push this cooler across a concrete floor versus pushing it across ice. So what factor are we talking about? What factor are we changing? We're changing the surface, okay? The material of the surface that it's in contact with. So that's one factor that might make it easier to move. And so in this lab that you guys are going to complete, there's 3 factors that you guys are going to determine. And so you can start thinking. I'm going to ask you to write down your hypothesis, which a hypothesis is basically just your guess about what's going to happen for the purpose of this lab. And so the purpose of this lab is, how do these 3 factors affect our ability to move something? So if we're using the example of the cooler, does the amount of mass or the amount of matter that makes up this object, does it affect how it moves across the floor? So in other words, would emptying the contents of this cooler help us move it across the floor? I think most of you can probably guess what's going to happen with that one. The effective surface area, so the surface area that is in contact with the floor, we should maybe add that in. That is in contact with the floor. So you want to think, if this had a wide-based bottom, is it going to be easier to move? More surface area in contact with the floor? Or if we say turn this cooler on its side and we only had this small amount on the floor, is it going to be easier to move? So that's what we're testing, the second thing. So we're testing 1, the effective mass. Does changing the mass make it easier? 2, does changing the amount of surface area that it's in contact with make a difference? And 3, I just already answered with the comparison between being on concrete or being on ice, the amount of the type of materials that are in contact with each other. Would throwing some oil down on your concrete floor make it easier to move this cooler across? So in the next activity, you guys are going to work through a lab. I've provided links for this lab, And I've also provided a lab outline for you to follow. So this lab is going to be your first, I think the first actual lab report that you're going to submit for marks. I know we did one gizmo, which you guys just answered some assessment questions after, but this is the first lab that you're going to actually hand in to me for marks. And so what you're going to need to do, depending on how you've found it easiest for yourself, is to either print the lab out, and you can handwrite your answers as you work through it, which you might actually find easier because it's an online lab. That way you can look at the screen and write your answers while you're working through it. But the other option is if you're liking the computer and you want to type up your answers, I've given you a word processing copy. So you can actually just open up a copy of that lab in another window, and while you work through the lab, you can fill in your answers online. If you're doing it by hand, remember just to submit it in a PDF format. And that's it. Good luck.